Hello, this is Prof. Manius. We're continuing a review of calculus and algebra for differential equations. And today we want to talk about the product rule and what its role will be for us, one of its roles. So let's get started. So this is a good old product rule. Now, the product rule is how you differentiate a product of two functions, and the rule is written up here. I'm not going to prove it. This form right here is how you're actually going to see it in differential equations, at least some of the time. And just a quick example, let's just do something easy. So for example, if you wanted to differentiate e to the 3x sine to the 5x, you take the derivative of the first one times the second, plus the first times the derivative of the second. That 5 cosine. That's what happens when you go too fast, which we can factor out at e to the 3x. And we have a 3 sine 5x plus 5 cosine 5x. All right, so that's all well and good. But how we're going to actually see it, at least a lot of the time, is in this thing here. So you might have an expression, something that looks like this. You might have a y prime, and let's make this something like tangent of x plus y times some function here. Let's call that p of x. And we want to write this so that this is going to be the derivative of y times some g of x, like so. Well, here the pattern's pretty clear. This thing, for this to be a perfect result of using the product rule, this will have to actually be the derivative of tangent. So what works here is tangent. You remember the derivative of tangent is secant squared. And then you'll find out that, well, of course, that's going to be the derivative of y times tangent of x, right? So that's one way you might see it used. A second way you might see it used is you might be given this. So you might have, let's say, y prime q of x plus y times, let's say, say sine of 3x. And you want to write this as something that looks like this. Well, in this case, what you have here is going to be an antiderivative of that, because remember, this is going to be the derivative of q. And you remember from calculus 1, this will work if you have y prime 1/3 negative 1/3 cosine of 3x. This will, in fact, equal the derivative of, because remember, the derivative of cosine 3x will in fact equal the derivative of minus 1/3 cosine of 3x times y. And let's check. Let's do a quick check to see if that's right. If I apply the product rule to that, we get the derivative of this, negative sine of 3x times 3. So we get sine of 3x times times y plus negative 1/3 cosine of 3x times the derivative of y, which is y prime. So in our class, we're going to practice going between these two different forms. Now, this, again, may look strange to you, but if you look ahead and you look at our chapter on first order your linear differential equations and slash integrating factor, you will see this idea being used. So I wanted to give you an idea of what it was like ahead of time, and thanks for watching.